Exercise Physiology Rhetorical Analysis by Samuel Toller. Introduction. For the first article, I chose Mechanotransduction for Muscle Protein Synthesis via Mechanically Activated Ion Channels. This article discusses how mechanical tension, such as overloading or stretching, are sensed by muscle cells and how those forces are converted into signals that elevate protein synthesis and, as a result, grow or maintain muscle. For my other choice, I did a video from Lift, Run, Bang on why mechanical tension is the true driver behind muscle growth. The video's central message is that mechanical tension, the force experienced by muscle fibers during contraction and stretch, is the primary driver of muscle hypertrophy. The video challenges the idea that metabolic stress, otherwise known as the pump, or muscle damage are equally important in comparison to mechanical tension. For my motivations. For the motivation of the article, Mechanotransduction for Muscle Protein Synthesis via Mechanically Activated Ion Channels are grounded in understanding how mechanical loading leads to muscle growth. The author, Timur Mirzoev, wanted to dive deep into the step-by-step process which leads to hypertrophy. He displayed a very advanced understanding of the current literature for mechanical tension and transduction. For the video wanted to emphasize that mechanical tension is the primary or even the only driver of muscle hypertrophy. The creator Paul Carter argues it's more foundational than the other commonly cited mechanisms, which are muscle damage and metabolic stress, or at least that it should be received much more attention in training design. Paul wanted to display an argument backed by the same literature in the article, but with a much more practically applicable approach. The intended audiences. The article's intended audience for mechanotransduction for muscle protein synthesis via mechanically activated ion channels is aimed for anyone with a predestined interest and advanced understanding of exercise physiology, specifically how the body translates mechanical forces into muscle growth or hypertrophy. The video from Lift, Run, Bang is intended for lifters who want to use a scientifically backed approach to optimize their training and maximize muscle growth. Also for those who show interest in the physiology but do not quite show a deep enough understanding for something like the article I analyzed. Logos. The article for Mechanotransduction for Muscle Protein Synthesis via Mechanically Activated Ion Channels uses logos the most. The author cites dozens of peer-reviewed studies, including in vitro cell studies, animal models, and human experience to support their claims. The paper also builds a logical model connecting mechanical tension to mechanically activated ion channel activation, to the ion influx of calcium ions, to signal transduction pathways like mTORC1 and P13K, which then translates into muscle protein synthesis and then hypertrophy. For the video used pathos the most. The video appeals to people's desire to get bigger, maximize gains, train smart, not waste time in the gym. Those are common fitness goals that carry emotional weight, frustration with lack of progress, and desire for visible results. The video taps into the irritation many lifters feel with bad advice. For instance, you've been duped into thinking soreness or metabolic burn equals growth, which isn't true. By positioning mechanical tension as a correcting error, the video gives a sense of clarity. For the vocabulary. For the article, Mechanotransduction for Muscle Protein Synthesis via Mechanically Activated Ion Channels uses very advanced scientific wording to explain the exact steps in the process of mechanotransduction. For the video from Lift, Run, Bang, he uses much simpler terminology but still scientific, and also uses persuasive wording to argue why mechanical tension is the main driver behind muscle growth. The visuals. Mechanotransduction for muscle protein synthesis uses a clear visual representation of shear stress and exercise, which translates through the calcium ion channels, and then it shows the protein pathways that lead to muscle protein synthesis. For the video from Lift, Run, Bang, he shows an example of how the proteins actin and myosin interact with each other to create mechanical tension. Thank you.